Good day everyone. So I am here to discuss about testing difference between two means of independent samples using t-test. So before we start, let's have our objectives. Number 1, understand the independent sample t-test. Number 2, compute the t-value of independent sample t-test. Then number 3, we need to identify the critical values. And the last, make decision and comparing t-value and critical values. And now, when we say independent samples, our samples are said to be independent if the members of the samples are unrelated to the members of the other samples, or samples are independent samples when they are not related, meaning both samples must consist of distinct t-test subject. Remember this procedure table. This is step 1. State the hypothesis and identify the claim. Our step 2, find the critical values. Our step 3, compute the test value. Step 4, make the decision to reject or not reject the null hypothesis. And our last step is the step 5, summarize the results. Remember also the two terminologies, the null hypothesis and the alternative hypothesis. When we say the null hypothesis, in a statistical test, null hypothesis is there is no significant difference between specified populations, any observed difference being due to the sampling or experimental error, meaning the two samples are not connected or there is no significant difference. Then the alternative hypothesis, this is the contrary of the null hypothesis, meaning there is a significant difference. When null hypothesis is rejected, there is a significant difference between the two samples. When the null hypothesis is not rejected, there is no significant difference between the two samples. And now, this is the formula for testing difference between two means of independent samples using t-test if the variances are assumed to be unequal. Test value equals the x sub 1 minus x sub 2 open close parenthesis minus mu sub 1 minus mu sub 2 open close parenthesis divided by the square root of s sub 1 squared divided by n sub 1 plus n sub 2 squared divided by n sub 2, where the x sub 1 is the first sample mean, the x sub 2 is equals to second sample mean, the mu sub 1 is the first population mean, the mu sub 2 is the second population mean, the s sub 1 is the first standard deviation, the s sub 2 is the second standard deviation, the n sub 1 is the first sample size, and the n sub 2 is the second sample size. Now, let's have an example. Example, the average size of a farm in Indiana County, Pennsylvania is 191 acres. The average size of farm in Greene County, Pennsylvania is 199 acres. Assume the data were obtained from the two samples with standard deviation of 38 and 12 acres respectively, and the sample sizes of 8 and 10 respectively can be concluded at alpha at 0.05 that the average size of the farms in two counties is different. Assume the population are normally distributed. And now let's start with the step 1. State the hypothesis and identify the claim. In null hypothesis, always assume that the two means are equal. So the first population mean is equal to the second population mean. Then in alternative hypothesis, the sign depends on the given problem. So our sign is unequal because hinahanap dun yung difference between the average size of the farm in Indiana County, Pennsylvania, and the average size of the farm in Greene County, Pennsylvania. So our claim will be the first population mean is not equal to the second population mean. Let's proceed to the step 2. Find the critical value. Since the test is two-tailed and since alpha is 0.05 significance level, and since our variances are not equal, the degrees of freedom are smaller of n sub 1 minus 1 or n sub 2 minus 1. So, yung ating n, where n is our sample sizes, in this case, the degrees of freedom are 8 minus 1 equals 7. We will use the smaller, yung pinakamaliit between the two sample sizes. So, mas maliit yung 8 kaysa sa 10. So, we use 8 minus 1 equals 7. So, from the distribution table, the critical values of 7 are positive 2.365 and negative 2.365. This is the T distribution table. We use it to find out the critical values of 7 with alpha at 0.05. So its critical values are positive 2.365 and negative 2.365. We proceed to the step 3 to compute the test value. So this is the formula for computing or getting the test value. So if the variances are assumed to be unequal. So let's proceed to the given. So our first and second sample mean will be equals to 0 because in the given, we do not have a sample mean. Then the first population mean will be the 191 acres. So this is the average size of the farm in Indiana County, Pennsylvania. Then the second population mean is the 199 acres. This is the average size of the farm in Greene County, Pennsylvania. So the first and second standard deviation will be 38 and 12. So given naman siya yung standard deviation natin. So the samples with standard deviation of 38 and 12 acres respectively. Then our first and second sample size, the 8 and 10. So given again siya, so our sample size of 8 and 10 respectively. So yung 191 and 199 acres will be our population mean because those are the entire measure of the land in Pennsylvania. Now we need to substitute the given value in our formula. So test value is equal to unahin na natin ang population mean because wala naman tayong sample mean. So the first population mean equals 191 minus the second population mean equals 199 minus 0, the sample mean divided by the square root of 38, the first standard deviation squared divided by 8 plus the second standard deviation squared divided by 10, the second sample size equals 191 minus 199 equals negative 8 divided by the square root of 38 is 1444 divided by 8, copy the 8, the first sample size plus the square root of 12 is 144 divided by 10, second sample size. Next one is equals to copy the negative 8, square root of 1444 divided by 8 is equal to 180.5 plus 144 divided by 10 is equal to 14.4. So then negative 8 divided by 180.5 plus 14.4 is equal to the square root of 194.9 equals negative 8 divided by the square root of 194.9 is 13.960659010 So the negative 8 divided by 13.960659010 is equal to negative 0.57330, or round up natin in 2 decimal, it will be negative 0.557. So our test value in this problem is negative 0.57. Let's move on to the step 4. Make the decision. So remember the decision rule. If in negative side, ma-reject lang ang null hypothesis if ang test value is less than in critical value. So hindi ito ma-reject if mas mataas ang ating test value in critical value. While in positive side, so if the test value is greater than in critical value, the null hypothesis is rejected. While if the value of the test value is less than to the critical value, the null hypothesis will not rejected. So in our case, since the negative 0.57 is greater than in negative 2.365, our null hypothesis is not rejected. And the last part is the step 5. Summarize the results. Since our null hypothesis is not rejected, we conclude that there is not enough evidence to support the claim that the average size of the farms is different. When raw data is given, we need to solve the sample mean or the population mean. So we have the formula for sample mean is the summation of x divided by n. Summation of x is the add all the individual value divided by to its sample size. Then ganun din sa population mean is so population mean is summation of x divided by n. Add all the individual value divided by the population size. Then the difference between the two is population mean is the whole or the entire population, and the sample mean is the sample taken in the population. If you already done to get the means, you need to get also the variance to get the standard deviation. We have the formula for variance. The variance is equal to n times summation of x squared minus summation of x opening close parenthesis squared divided by n times n minus 1. N is the sample size, then summation of x is only squared all the individual value, then get the summation of it. So yun yung magiging summation of x squared. Then summation of x opening close parenthesis squared, only squared the mean, your mean, squared the mean After that, so kukuha mo naman yung standard deviation. So in the standard deviation is only the square root of the variance, or the square root of n times the summation of x squared minus summation of x open close parenthesis squared divided by n times n minus 1. So kapag nagawa mo na or already done na nakuha mo na ang sample mean or the population mean, then the standard deviation, you may proceed to the step 1 to 5 to get the test value or to make the problem solve. And now let's move on to how to get a confidence interval for the difference of two means independent. So ito'y kinukuha upang malaman kung pasok ba ang ating two means in computed intervals. So we have a formula: the first population mean minus second population mean is greater than in first sample mean minus second sample mean minus our test value, the square root of our first standard deviation is squared divided by the first sample size plus the second standard deviation squared divided by second sample size, but less than in first sample mean minus second sample mean plus our test value, the square root of first standard deviation squared divided by first sample size plus second standard deviation squared divided by second sample size. So this is the example or the given problem. Find the 95% confidence interval for the data in our given example. So substitute the given value in our formula. So the value of our population mean will be the value of our sample mean. So first population mean minus second population mean is greater than in our first and second sample mean, the 191 minus 199 minus our test value is 2.365, the square root of 38 first standard deviation squared divided by our first sample size plus our second standard deviation squared divided by our second sample size equals to 10, but less than in 191 minus 199, our first and second sample mean plus our test value is 2.365, the square root of 38 squared divided by 8 plus 12 squared divided by 10. So we need to compute this directly. So 191 minus 199 is negative 8. Negative 8 minus 2.365, the square root of 38 squared divided by 8 plus 12 squared divided by 10 equals siya sa negative 41.02. Then compute also this in directly, the negative 8, 191 minus 199, negative 8 plus 2.365, square root of 38 squared divided by 8 plus 12 squared divided by 10. So we got 25.02. So we conclude that our first population mean minus second population mean is greater than in negative 41.02 but less than in 25.02. So since the zero is obtained in the interval, in the computed interval, our decision will be our null hypothesis is not rejected because the zero is contained in the interval. Let's have a exercise. The mean noise level of 20 areas designated as casualty doors was 63.1 dBA. dBA means yung noise level, and the standard deviation is 4.1 dBA. The mean noise of 24 areas designated as operating theaters was 56.3 dBA, and the standard deviation was 7.5 dBA. At alpha at 0.05, yung significance level, can it be concluded that there is the difference between the two means? So let's do it.